All right. So, I think as developers, a lot of the conversation around AI today is about how it makes us better as developers or faster as developers. And maybe even some scary things like replacing developers, which I don't believe in at all. I think that's just not the reality of how these tools work. But as Brian and I have been using things like GitHub Copilot and Cursor and the ChatGPT app and Claude Code, it's really had our brain kind of buzzing around like, well, this is great for me as a developer, but how do I pass these productivity gains, the ways in which I'm getting faster, onto my users? What if we built Angular apps that worked the same way as these developer tools, where our users of our Angular apps get to have really pleasant user experiences, really joyful user experiences that are all AI enabled. And so that led us to the question, what would an Angular app specifically look like if intelligence was a drop-in primitive? If in any Angular component or any Angular service, you could reach out for intelligence and consume it in a really pleasant way directly in your component layer. So before we get into maybe some of what that looks like, just some quick introductions. My name is Mike Ryan. I'm the co-founder of Live Love App, and I'm also a Google developer expert in Angular and web technologies. And you've probably used some of my open source before. I'm one of the co-creators of NGRX. So if you've ever gotten particularly frustrated at a complex effect, I'm the one to blame for that. I apologize, and you're welcome. And I'm joined.
I don't know. I mean, a complicated effect that might be more due to RxJS and some of the nesting or whatever you're doing there than an effect is just, anyways. My name is Brian Love. I'm co-founder here at Live Love App as well, and Google developer expert in Angular. Glad to be here.
So Brian and I are exploring this idea of generative user interfaces. And this phrase hits on, this idea of generative AI. And what do we do with generative AI? Well, when I'm talking with an AI agent in ChatGPT, that AI could be generating text. In fact, it's often generating text. I can use a tool like Dolly or Sora to generate images. Maybe I'm using Google's VO to generate videos. And so this idea of generative user interfaces is that we're going to use the AI not to make text, images, or videos, but to actually generate user interfaces on demand in response to whatever it is that our user is trying to do. And I know it's kind of an abstract thing. So what I want to do is I just want to show you a quick demo of an Angular app. And I'm going to kind of breeze through 5 things that you can build in your Angular app using generative user interfaces. And then we're going to go do an actual workshop together where I'll show you how to build a little bit of a generative UI. So for my app here, I've got a smart home application that I have written in Angular, and it has all of the lights that are in my apartment here. So I have lights for the guest bedroom, the living room, the main bedroom, so on and so forth. And I also have some scenes that I can apply to control those lights. So to me, generative user interface is at the basic level all about accelerating your users. It's about giving them shortcuts that help them move through their workflows a little bit more quickly. For example, if I were to go add a light, well, in my living room, I have entertainment ambient lights, one, two, three, four, however many I've got. And maybe I want to go add a fifth one. I'm configuring my system. Well, it'd be really nice if Angular form inputs just had tab to complete experiences all throughout them. So you can see here, I've started typing in living room entertainment, and it's automatically completing it to be living room entertainment ambient 5, because it knows that I have 1 through 4. So it's picking up on that pattern, and I can just hit tab to accept it. But it's more than just completions inside of form inputs. Another thing you can build with generative user interfaces is shortcuts directly in forms. So for example, if I wanted to make a scene that dimmed those living room lights, well, I'd have to go through this form and pick each living room light one by one and configure it sort of very manually, right? This is why we build forms, is to let users configure this. But with AI, we have the ability to convert natural language into structured data. So how about we don't do this? Instead, I'll just type in what I want it to do. I'll call this dim living room to 30%, and we'll use AI to find all the lights that probably deserve to be in this scene and suggest to the user the right brightness level. So that way they can just add it directly into their scene and get really sped up. But it's more than just like making forms easier. Going back to that light example, if I went and added this light, well, there's a bunch of scenes I might have to go fix. I have all those living room scenes. That'd be a real chore to go do. So what if instead of making our users go through those workflows, we used generative UI to suggest to them the next step that they might want to complete? Oh, yes, I do want to add this new light to my living room chill scene with brightness 40. And I do want to add it to living room off scene with brightness 0 and the living room on scene with brightness 100. Those are really great. And now I don't have to go touch those forms at all. With generative UI, I've gotten to move a little bit faster. And it's also about, well, chatbots. Lots of interest right now around building custom chatbots. But with generative UI, chat could be so much cooler. So instead of responding in text, when I ask a question like, what lights are in the living room? Instead of getting back a boring text response, we can build things with generative UI where it's streaming our actual Angular components back to us. And these are real components. Like I can go interact with them. Here, I'll scroll down so you can see that these are live and connected to my user interface. And the AI agent has done lots of work for me. It's called my Angular services for me. It's streamed a response right back. But it's even more than that. Like we know that AI agents are really good at generating code for us, for example. So let's build entire apps that are modeled around generative UI. Like I've spent so much time building Angular apps that just configure forms on behalf of the user. But why don't we just let the LLM do that? Like if I want to see a pie chart of cumulative product sales, for example, let the user ask that question and let's use our AI agents to connect what the user is trying to do directly to our component layer. Oh, I don't want a pie chart. Maybe I actually want a bar chart of product volume over month. And it just sneaks right on in. It generates the chart for me in response to the user. Oh, I don't want that legend at the top. I want the legend at the bottom, for example. And so this idea with generative UI is that we could really build brand new user experiences that we've not even really begun to imagine. So part of our exploration of this is through the creation of a framework called Hashbrown. And that's what we're going to be showing you today. Hashbrown is a framework for building really joyful generative user interfaces. And it supports both Angular and React, though it's proudly Angular first. And we support models from OpenAI, Google, and Writer. So with that, Brian and I would like to kind of just walk you through what it would be like to build with Hashbrown. To kick it off, let's kind of talk about how it integrates into your Angular application. First off, you have to bring your own backend. Right now, we support backends or Node.js-based backends. And depending on your model that you want to use, for example, if you want to use one of the OpenAI models, you would first install the right Hashbrown adapter package for it. So you would install the Hashbrown AI OpenAI package. And what that package is going to do is it's going to communicate with the AI provider of your choice and form hardened streaming responses. We're taking care of all the logistics of talking to that model, getting responses back out, making them ready to be streamed back with all the error handling all done for you. From there, you're going to use Hashbrown's main set of packages in your application code. And Hashbrown gives you chat state management for building chat-based experiences, or even experiences that don't look like chat, like that pie chart or that charting one that I showed previously. It has structured data capabilities, and we'll get into this in this workshop today, that lets you get structured data out of large language models. And it even comes with a JavaScript runtime, so that way you can dynamically generate JavaScript on the fly and run it safely in the browser. And so using Hashbrown, you can build AI-powered services and components. Hashbrown is made for Angular 20. It is based on signals or uses signals to expose AI as a primitive in your application. And we are implementing the new resource interface. So I'm going to be really excited to show you this. And this might be, for some of you, the first time you've gotten to see the resource interface. But it's a really great declarative and reactive way to generate or get responses in response to a signal changing. So with that, let's kind of just jump right into some application code. As Chris mentioned, there is a GitHub repository. Let me kind of start at that spot so that we can all be on the same page here. So if you go to liveloveapp.com/hashbrown Angular intro on GitHub, you'll find the brief 1-hour intro to Hashbrown. You can go ahead and check out the code, and then you will need to be on node version 22 or higher. We recommend always using NVM to manage node versions, and then go ahead and install the dependencies. You will need an OpenAI API key, and I think that there's just a few of us here, and so I'm going to share an OpenAI API key with y'all. I'm going to delete this API key in an hour, so whatever demo code that you are using today, we'll have fun for the next hour together using this, and then at the end of it, you will need to supply your own OpenAI API key. If you want to, you're also welcome to swap it out for the Google package if you want to use one of the Gemini models, or the Rider package if you want to use one of those as well. But for this workshop, we're going to keep it focused on it. Yeah, you can share on Twitter. Please don't actually share on Twitter. It's tied to my personal credit card, and it will auto renew. So let's all keep an eye on this little email app down here. And if I get a red dot, that might mean we've gone over on our budget on that. So fingers crossed, I think I've got enough balance in there for us to play around with this today. So yeah, you're going to want to clone the repository, get the dependencies installed, copy that API key that I just shared, and then inside your application code, what you're going to do is you're going to create a .env file. You're going to, in that .env file, export an environment variable called OpenAI API key. I'll also throw that in chat. And then just paste that API key that I shared with all of y'all into there. Now with that, let me show you what we're going to build. We're going to build kind of a modified version of that smart home app that I showed previously. So once you have the code downloaded, there is a complete branch that has the finished challenge put together for you. So you're welcome to kind of just make sure everything's working by checking out that complete branch. Totally cool with me. And then you'll just run npx ng-serve app. Oh, don't autocomplete that. Serve. Zoom was just insistent that I had misspelled it, and I was not. Once you've done that, you can go to localhost 4200, and you should see a really consolidated smart home application with scenes and lights in it. And yeah, if you have the API key set up successfully, then you can do that add light demo that I was showing earlier, where you should get a nice tab to complete experience. That's a good sign that everything has been configured. So I'll give folks just a minute to kind of get caught up with what I just did. As a reminder, I went to the repository, I cloned down the code, I installed the dependencies, and then I set up my OpenAI API key in my .env file, ran npx ng-serve app, and yeah, the new NX console is super awesome. Shout out to the NX team for building this. It looks great, and it's been a real joy to use for this project. And once you've got that done, you should be able to run the application and see some of the AI features working that I had just previously demonstrated, including that nice tab to complete when you add a light. All right. So I'm going to kill this for just a second. There's no way to copy the API keys from Zoom. That's so sad. That's so sad. How
Hmm.
get around that? I think I'm going to make a secret GitHub gist, and that's how we'll deal with this. And then I think I can paste y'all a link into it.
It might be a setting we can change, but there's so many settings in Zoom. It's so hard to find anything.
Hmm.
I'm going to do just.github.com. I'm not signed into this. 1 second, y'all. Sorry about that. All right. Hopefully that'll work.
That worked, Mike. For me, anyways, I was able to see that.
Cool.
Do not share this, please, or I'll go probe, he says. I like it.
Real talk, as our software engineer on That's Ben would say, real talk, it really doesn't cost all that much. I think you could have a lot of fun with Hashbrown for just $1 of
$1, yeah.
You can
Yeah,
go
it's pretty cheap.
far. It's getting cheaper and cheaper. I think I saw a quote from maybe a Sam Altman last week that essentially the price of AI and AI generation will trend towards the price of electricity as more and more players get into this space. You know, at the end of the day, all they're trying to do is they're trying to get as much money from us as possible by running electricity through rocks. And hopefully it'll require less electricity over time and fewer rocks to do it.
So create the .env file, drop in OpenAI _ API key equals, drop that key in, and then npx nx serve app, and we're good to go.
All right. So I'm going to kill this, and I'm going to go to the main branch. And let me talk to you a little bit about how you configure Hashbrown. Once you have your OpenAI API key, the way this repository is set up is there are 2 folders. There's the app folder. We'll be spending most of our time in the app folder. That's where the Angular code lives. And there's also a server folder where I have a really simple Express application set up. And with Hashbrown, God, see, this is what I'm talking about when I'm talking about joyful experiences. Like, I've not even done it yet, and it already kind of knows what I want to do, but I don't want to spoil it just yet. The idea with Hashbrown is that you bring your own backend in play. And there's a couple of reasons for that. First off, we don't want to actually ship our API keys to the front end. That would be terrible. And so this gives us an opportunity to safely and securely provide that API key to Hashbrown. And then the second benefit of it is it, lets us implement authentication or, any kind of user tracking. And then third, there's going to be some parts of Hashbrown that we'll show today that maybe you want to actually keep out of your front-end application code and instead move to your server code. And so this is kind of a great opportunity when you're configuring Hashbrown to set up an API endpoint that handles all of those concerns for you. So the first part to keep in mind is we're going to first want to expose a chat endpoint, and it can be any URL you want to. This is configurable on the front end. And you're going to want to allow Hashbrown to be able to make post requests to that API endpoint. And so I'm going to be using Express, though a lot of this should work in whatever framework of your choice, whether you're using like Nest or Koa or what have you. But essentially, the first thing I want to do is I want to get the params out and make sure that I've cast the types of those correctly. So when Hashbrown makes a request to this endpoint, it's going to pass what we call the completion create params as the body of the request. And in order for you to read this in like Express, for example, you need to make sure that you've used Express's JSON middleware. And this is going to vary based on the Node.js framework of your choice, but you want to make sure that that body has been parsed as JSON before you pass it off to the Hashbrown adapter package. This request or completion create params includes a lot of information, and you're able to override it. This includes model, system, messages, response format, tool choice, and more. And so with that request, the next part of it is to actually generate the response using the Hashbrown adapter package. So I'm going to set up a thing here called response, and I'm going to use Hashbrown OpenAI's .text for stream text, and the
you go 2 equals. There you go.
Yeah. It's kind of annoying actually using generative code editors when you're trying to do a workshop, because it's just like spitting out a bunch of stuff at me before I get it. I kind of want to turn it off. Anyways, so there's going to be 2 parameters that we need to pass to this text function. And the first one is that API key. So we're just going to call process.env.openai API key, pass that in. And then the second parameter we want to pass in is that request. And that's pretty much all we have to do in the backend to actually start generating responses using Hashbrown. So now that we have this response, if I hover over it, we'll see that it's an async iterable, and the iterable is going to be iterating or producing these chunks of binary data. What Hashbrown is doing is it's not just communicating with the AI provider of your choice, but like I said, it's forming hardened streaming responses. And so once I have these, I actually need to start writing it out so that my front end can consume it. To do that, I'm going to do request or response.set header. And I'm going to set that content type header to be application octet stream. Basically, I'm going to be responding with a binary response. And then from there, I'm going to use for await syntax, and I'm going to iterate over every chunk of that response we created, and I'm just going to write out that chunk. And then once we're done, once the for loop is finished, it's going to call response.end. The nice part of this is that not only is it going to stream the responses back, but if there's any errors that occur when generating responses, those errors are also encoded in these chunks for us, and the errors will be threaded all the way through Hashbrown for you onto the front end. So once you've done that, I can now go rerun the application. And at this point in the app, you should, like I said, be able to do something like go add scenes, and I'll say dim living room to 50%, and you should start seeing some of the AI features work. If it's not working correctly, you should get a really nice error message in the front end. So I'll give you just a couple of minutes to take a stab at that on your own. Please feel free to ask Brian or I any questions. I know we've only got like 30 more minutes, and I've got a ton of material I want to go through. So I'll probably keep it a little snappy, but don't worry. Like I said, there is that complete branch with the entire bit of code for you to play with if you happen to fall behind. But yeah, give you a couple minutes. Please feel free to ask a question too. We love getting questions.
And we're recording this, and we'll have this posted on the YouTube, the ng-conf YouTube channel within the next week or so. So if you ever want to watch this again and be able to pause it at any point, we'll have that available.
Awesome, thank you. Now I have to make sure I don't have breaking changes.
I have a question, maybe. Can Hashbrown, can it tell Hashbrown, when generating the components? Let's say I have a reusable library in my company and I have the components there.
Yeah.
Can I tell Hashbrown, hey, use my reusable library and create the components from that?
Yeah, like kind of component discovery. That's a great question. These large language models currently have a bit of a ceiling in terms of how many tools or components it can reasonably know about. And I'd say that cap today is about 50. And so I've been hesitant to do any kind of like loading lots of components at once with Hashbrown, because I think while that cap is somewhat healthy and you could build a lot with it, I would hate for it to be the kind of thing where a lot of it got like consumed automatically and you didn't know about it. So someone has to see the code again. There it is. Go ahead and post that there for you. So yeah, with that in mind, not today, but as models get better, I think it would be really awesome to do that kind of thing where you could just like automatically register a bunch of components.
Catalina, I also dropped a link for the docs, and so feel free to check out the docs for the OpenAI platform, and you'll find very similar code there.
Right. So go ahead and move on. I know I'm moving fast. If you need me to slow down, feel free to say so. But just in the interest of time, let's kind of move on to the next section here. So let's start off by creating a really simple chatbot, not one that's using components, just a basic text-based chatbot. To do that, I'm going to close main.ts, and the component that we're going to be modifying pretty heavily tonight is this chat panel component. You can find it inside of the app folder. Go to source, app, chat, and then there is a chat panel component. And this component is pretty small right now. It's going to show a loading indicator for us if we're in a loading state, and I'll show you how to wire this up. And then it's got an area for us to write or generate some messages. I'll show you how to do this in a second. And it also has a composer component where the user can actually type in and send us a message. So to use Hashbrown and to do a simple amount of chat, I'm going to create a chat property on this component. and I'm going to use Hashbrown's chat resource. Now, this is going to provide us or create a chat resource for us. And to create a chat resource, you need a couple of parameters. First, you need to supply it a model. And for this workshop, we're going to use GPT 4.1. This is, I would say, like OpenAI's current flagship model of their non-reasoning models. So OpenAI has, I'd say, two families of models right now that are worth considering. There's the non-reasoning models. If you use ChatGPT's app, it uses GPT 4.0. That's sort of like their most widely used non-reasoning model. GPT 4.1 is available for developers, and it's got really great capabilities. I think it has really fantastic performance. It's kind of my favorite model to play with. And then there's also a set of reasoning models. This would be like O1 or O3 or O4 mini. These are incredible models because they take time to reason about their responses. But I also find that because they're a little slower, they're not as much fun to play with, even if they're maybe a little bit more capable. The next part that you have to provide is my favorite part of AI engineering, which is a system instruction. And the system instruction is where you're going to do the majority of your Hashbrown programming, except programming is kind of a loose word because I'm not doing any TypeScript. I'm going to be writing all of this programming in natural language. This is where you're going to tell the AI how you want it to behave. It's your opportunity to set the tone of the conversation and set the personality and give it context as to what activity is trying to accomplish. So here I'm going to say you are a helpful assistant that can answer questions about the smart home. It's also helpful to tell it that kind of where you're interacting with it. So I'm going to say that the user is chatting with you in a web app that manages their smart home. So this little bit of instruction really kind of establishes how it's going to behave. It's going to behave in a way that is helpful or in a way that is assistive, and it knows now that it's in a web application and that it's going to be, sort of in a smart home. The next part you'll want to do is maybe set some rules. And these rules are going to be, really instructive as to how it's meant to behave. So I'm going to give it a rule like, if you don't know the answer, just say so. This happens to be a really great rule, and you're welcome to kind of play with it. If you don't have this rule in place, you can ask it a question and it will sometimes just make something up. But with this rule in place, it's going to really constrain itself to the knowledge that it has available to it. Once you've done that, that's really all you need to set up a chat resource and start building a chat conversation. And so I'm going to go down into this send message method down here at the bottom. And instead of just console logging the message, I'm going to call this.chat.sendMessage. And I'm going to form a message ready to be, sent over to the LLM. So in this case, I'm going to use the user role for this message, and I'm going to set the content to be what the user has provided to me. From there, I can start consuming the value of this resource. So I'm going to go up to the top, and instead of if false, I'm going to do if chat.loading or is loading. This allows me to read as a signal whether or not we're in some kind of loading state, and I'll use that to show the loading bar. And then inside of chat messages, I'm going to use a for loop for message of chat.value. That's how you read the value out of a resource, as you call the resources.value signal. And I'm just going to track the index. In this case, the index is a stable reference. The order of messages is guaranteed not to change with Hashbrown. So with that, I'm just going to do, a little chat message here, and I'll also spit out the messages role. So now that I've done that, I'm going to go back to my app and let's see if it works. Hello, how are you? We could see the loading bar showed up, and then the assistant responded, hello, I'm here to help you with anything related to your smart home. How can I assist you today? Fantastic. That shows that everything's been configured at this point, and it is adhering to that system instruction. So with that, I'm going to pass over to you, give you some time to try it out on your own. I'm sure Brian already linked documentation to writing system instructions. It's a full guide on how to write them. Oh, there's actually something I want to show before we get to this. I'm so sorry. There's one more thing. With Hashbrown, in any of the resources, you can provide a debug name. And what this debug name is going to do is it's going to let us actually debug the chat as it's going on. So that I've supplied a debug name, I can use the Redux DevTools extension, which you can get on the Chrome extension store. And you can use that to actually introspect the state of chat. So if I say hello here, you'll be able to see all the different steps as you go through it, and you can actually kind of dive in, see what the messages are, what the state of it was, and kind of see how all of the text got generated. So definitely recommend passing in a debug name as we go through this workshop. It'll be a really big help in debugging what's going on. So yeah, sort of here's your challenge. Let's go ahead and write up your first chatbot. So you're going to do what I just did. You're going to open up that chat panel file, and then you're going to create a chat resource inside of it. You're going to use Jeopardy 4.1 for the model, and then provide it a debug name. It can be whatever you want to. And then give it a very simple system instruction. And feel free to have fun with it. Like Hashbrown's a joyful thing. If you want it to be a little snarky, you can do that. If you want it to be terse, you can do that. If you want it to only respond in haikus, like you can do that with that system instruction. So I'd encourage you to play around and have a bit of fun with that system instruction. Once you've done that, implement that send message method and then use a for loop on that chat resources value to print out the individual messages. It's yeah, kind of while I work on that. It's just really does. It's a lot of fun to me that system instruction works the way that it works. I love that with AI programming, you do a lot of it in natural language. I think I've always dreamed of getting to program in that way, where you talk to the computer and the computer kind of listens to what you have to say.
Was there a testing library like Cucumber or something where that was the whole goal of like writing QA tests in like a natural flow? And then
Yeah.
that would get like converted over to some sort of like instruction set that then a test runner would execute. It
Working
always
that.
felt like a dream come true, but I don't know if a lot of people use it or if it was, yeah, I'm not sure. But I remember vaguely doing some of that, and it seemed like a really good opportunity to let QA big companies use it. Yeah, there you go. Yeah. So this is kind of the same thing, maybe it's like kind of Cucumber-esque, where you're writing the system instruction and you're kind of, like you said, setting that tone and the instructions, and here's the task at hand, here's the goals, here's some like important instructions, maybe do this or don't do that, along with providing really good examples. And I think that really helps with the few shots. And so that way you can get hopefully a good response of the LM on that initial response.
Go to ask the bot now. Just ask it, how is
And
the
say
bot?
hello. Yeah. We haven't wired up any tools. We haven't wired up any components or anything like that, Catalina. So at this point, you're just chatting with GPT or Jeopardy, basically, without any sort of like context other than what you give it.
What is going on there?
That's funny.
I'm surprised you're getting that thing. You might not be on the right branch, or I don't know that the 500 error codes that
Yeah, I'm not sure either.
yeah, the fact that it responded to you with lights tells me, oh,
We didn't start the server. Yep. And yeah, if you got the lights, you might be on the complete branch. Or maybe your cursor AI suggested that you wire tools up already.
and yeah, that will run the server, though I will say that npx nxserve app should have also spun up the server for you.
Yeah, if you're getting 500 instead of a 404 or something, I would, yeah, you might want to.
Okay, cool.
There you go. Cool.
All right. Going to move on to the next step because we're going to actually replace a lot of this code in the next step. So if you're still working on it, no big deal. But, you know, like I said, with Hashbrown, the idea is that we have generative user interfaces where we actually let the large language model create an entire UI in response to whatever the question is. And so I want to show you how you do that with Hashbrown. I'm going to jump back to the code here. I'm going to close these dev tools. And what I'm going to do is I'm going to swap this chat resource for a UI chat resource. And a UI chat resource works the exact same, except you'll see that I'm getting an error because now I have to provide it with a set of components. And with UI chat resource, the LLM is always going to respond in the components that you expose to it. So right now, it's kind of an illegal state that I'm in. I have to provide at least one component, otherwise it has no way to respond back to me. So to expose a component, Hashbrown comes with an expose component function. And what this is going to let us do is it's going to let us take any Angular component and basically describe it to the large language model. That way the LLM knows how to use that component when creating a response. So inside of this chat folder, there's a number of components that we're going to be kind of working with today, along within the lights folder. And the first one that I'm going to show you is this markdown component. It's pretty simple. It's just using the ngx markdown component that I grabbed off of npm, and it comes with some basic styles to style up the markdown that gets created. And you can see here that it has exactly one input called data. So using expose component, I'm going to pass in that markdown component. So the first argument is the actual component class. And then the second argument is going to be an object where we're going to just give it some metadata about what this component does. So the first thing I'm going to do is I'm going to give it a description, and I'm going to let the LLM know what this component does. And this one shows markdown to the user. The next thing I want to do is I want to let the LLM actually bind or generate data that binds to that input. So Hashbrown lets you do that with input here. And if I hit control space, you can see that it knows that I need to supply some way to bind data to this particular input. And the way that we do this with Hashbrown is using a custom schema language that we call Skillet. Skillet is an LLM optimized schema language. What that means is that we are doing everything we can at an API level to let you be successful in describing structured data to large language models. It provides a lot of types so that you get strict type safety. I hope you'll find that the type experience with Skillet is really ergonomic. As you define structured data using Skillet, you'll always get really good type results back out of it. As you can see, it's highly descriptive. Not only are you just describing the shape of your data, but you're also providing natural language descriptions of what this data means. That way, as the large language model is being asked to generate data matching this, it'll have the best chance of succeeding with some of that additional context. Another benefit of Skillet is that it generates really clear error messages. And this isn't just useful for the developer. If you have really good error messages and the LLM makes an error in generating data that matches this schema, well, then we can take those error messages, send them back to the large language model and ask it to try again. And that's a really successful strategy. We might see it as we get into some of the more complex examples where maybe it hallucinates a token somewhere or something like that. And so Skillet is designed to print good error messages back to the LLM. And then finally, all that streaming that I was showing you earlier, where it was actually streaming in the UI, is built on the fact that Skillet comes with a streaming JSON parser. So these large language models can be fairly slow at generating data, and it would be really sad if we had to wait and wait and wait until it finished before we started showing a result back to the user. And so Skillet knows how to eagerly parse JSON as the large language model is generating out the JSON for our schema. So to use Skillet, you essentially, it's kind of Zod-like or Zod-ish. You're going to import the S namespace from Hashbrown AI/core. And then on S are a number of functions for defining basic data types. So here I'm defining a number, and then the first parameter in any or almost every Skillet type is a plain language description of what it does. You can also do strings, and not shown here are booleans, integers if you want to constrain numbers even more tightly, null if you want to accept a null value. And once you have those primitive data values, of course, you can wrap them up into objects. So you can see here that, I'm asking it to generate a full object for me with a light ID and a brightness on it. And then you can also do arrays. And as I mentioned, Skillet has the ability to handle streaming JSON. And the way you do that is that on any array, object, or string, you can just drop the streaming keyword right on in. And now that I've added that streaming keyword to this array, now as the LLM has generated enough JSON to match the inner object, it'll go ahead and parse that and pipe that through to your components as you're building generative user interfaces. So now that I've got Skillet available to me, I'm going to go back to my code here. And for this data, what I really want is, and I'm going to import S from Hashbrown. What I really want is a string for the markdown content. So I'm going to hit save, and I'm going to go to my app. And at this point, I need to do one more thing. Now that I've switched this over to being a UI chat resource, above here, this isn't going to work anymore. The content is now a rich Angular interface. And so I'm going to delete all of this code here in this entire for loop. And I'm going to use the chat messages component that's already been written here. So I'm going to use app chat messages. And then I'm going to bind to the messages input on it with chat.value, and I'm going to make sure that it is included in the imports of this component. So now that I've done that, I'm going to hit save, go back to my application, and I'm going to ask it to write me a poem about writing AI-powered Angular apps. And you can see we're now in a pretty long loading state. And we're kind of waiting and waiting and waiting and waiting. And this isn't particularly fun. Oh, now we finally got our final result. If I go back to my app, I can fix this really easily. This string, well, I want to go ahead and eagerly parse that markdown. So let's call this a streaming string instead. And now that I've added that streaming keyword, I can go back to my application, paste that prompt back in, and now we're streaming that markdown directly into our Angular component, and we can see that we are getting that result a lot more quickly. So with that, I'm going to give you all an opportunity to take a stab at it. Here's your next challenge. Go ahead and refactor the code that you've got to use a UI chat resource. So you're going to add a components array to the chat resource. And then you're going to use that expose component function to describe the markdown component to the large language model. And you can import that from the same folder. It's just in markdown.ts. Make sure you use the description to tell the LLM what it's going to do. So tell it that this shows markdown to the user. That way it knows what to do with this component. And then use a streaming string to bind the streaming markdown to that data input. Once you've done that, I realize now you're going to also have to do that part where you swap out the template with the chat messages component. I know that's not in the instructions here. That's my bad. I'll go ahead and just copy that code out and put it in to chat. That way you can kind of see how to do that. So also put that in your template, replace that for loop that you wrote previously with that little bit of code. I'm kind of excited. This is the first time I've ever actually got to do a Hashbrown workshop. I've gotten to do a few Hashbrown talks now, but first I'm getting to teach how to use it. So definitely be some bugs in the slides as we go through it.
No problem. It's really cool. Really enjoying this.
And I've not got any emails from OpenAI yet, so I think we're doing great on our consumption so far. It's not working. Let's see. What error message are you getting, Catalina? It might be.
Did you switch to UI chat resource? Oh, I know you've got that in the first thing. Meter 500 to the API still. Okay. Yeah, that might work.
Yeah, if the complete branch doesn't work, that tells you that maybe the API key wasn't configured correctly in the .env file.
Mm-hmm.
Hopefully that'll let us know what's going wrong or right. Yeah, I work on Hashbrown every single day. And I'm running this demo many, many times a day. And I just went and looked at my OpenAI dashboard in the past month. I have spent $7 on API credits. And I think that's actually shared across the Hashbrown team. So yeah, these costs are definitely coming down. Those definitely worth paying attention to and keep total cost.
Yeah, I've been playing with Gemini and Firebase a little bit lately, and it's been very, very cheap.
Mm-hmm.
Definitely coming down in price.
The token size also too on a lot of the component responses, it's pretty thin, right? I mean, it's wiring up based on the schema and the output and input that you provide. I guess just the input, but yeah, I mean, it's not like you're sending back loads and loads of volumes of text.
All right. I'm gonna move on to the next step of this while y'all are still working on that, which is, we've got our Angular components that are now being rendered. We've got this markdown component, but we want the large language model to do more than just render components. Would it be great if it could call services for us? I'm gonna go back to my code, and at this point, things are running great. I've got my markdown component, but what I'd really like to be able to do is I would like it to be able to show a light to the user if the user asks about lights. So the first thing that I'd have to do here is I'd have to at least expose the light component to it. So I'm going to go ahead and do that. I'm going to expose the light card component, which I have imported from the lights folder. There's a light card component in here. And for the description of this, I'm going to say shows a light to the user. Always prefer this over text. That way it knows, like sometimes it might choose to put it in text when you really just always want it in the light card. This is going to let the LLM know that we always want, when it's showing lights to the user, to use the light card to do it. And then the input here is going to be this light ID input. And instead of a streaming string, I'm just going to use a regular string because this is going to be a UUID, right? And so it doesn't make any sense to have streaming UUID. We only care about loading the light once we've actually got the full UUID. And so that's kind of one of the nice parts of Skillet is you get to opt into or opt out of that streaming capability as needed using that streaming keyword. But how's it going to know like what the ID is of a light? Well, we're going to need to let it call our Angular services to do that. So in addition to components, we can give the UI chat resource or any of the resources a set of tools. And this is quite literally like a toolbox. The tools that we supply in here are going to let the LLM, or the LLM will pick a tool from the toolbox if it thinks it would be helpful in trying to satisfy whatever the goal is that it's trying to achieve. So for example, if the user asks what lights are in the living room, we would need to give it a tool to get the list of lights. And if we give it a tool that gets the list of lights, then whenever it sees that question, it will reach for that tool, use it, and then it'll take the result of that tool to respond to the user. So inside this tools array, I'm going to use Hashbrown's create tool function. And I'm going to create a tool called get lights. And this is going to get the lights in the smart home exactly. And so then you're going to give it a handler function, and this is going to be an async callback. And this is all within Angular's dependency injection. So right here, I'm just going to inject the smart home service using the inject function. From there, I'm going to return smarthome.fetchLights, which is going to reach out and go fetch the lights. And if I hover over this, you can see it's just going to give us a promise back of a list of lights, and that's great. That's all I want to do to respond to this particular tool. So now that I've done that, now that I've given it the get lights tool and given it the light card component, I'm going to go back to my app now, and I'm going to ask it what lights are in the living room. So you can see it ran get lights, and then it responded to me and gave me the components. It knew how to kind of wire that all up. And if I open up those Redux dev tools, we can kind of go and see what exactly it did. So I'm going to expand this messages list. We can see the user message, what lights are in the living room. And then the first assistant response, the first thing the LLM did was it didn't generate any content. Instead, it called a tool, and it can actually call multiple tools in a single message. So we can see that it called get lights, and Hashbrown fulfilled that by calling that callback function. And we responded with all the lights and the IDs, the names, and the brightness levels. And so the LLM was then able to use this data to form a nice response back to us, and it described the UI that we can see here on the left. And then that got generated for us. One of my favorite things that I just got to show you is that, Brian kind of mentioned some internationalization at the top of this. The really cool part about generative UI is that this works pretty much in any language that I would want to without any work on the developer. So my fiance, she's from Maharashtra in India, and she speaks Marathi. And I have been trying to learn a little bit of Marathi over the past few years as I've gotten to know her. So if I use a little bit of Marathi and I ask what the lights are in the living room, without any additional work on my part, the LLM was able to understand that in that language and fulfill the request back out to me. And so to me, like one of the greatest parts of generative UI is that it's going to broadly expand UI capabilities to a lot of different users from a lot of different places with a lot of different abilities too. Traditional application where I'm clicking through menus might be hard to navigate with a screen reader, but with a chat experience or generative UI, you can really shortcut that or reduce the amount of friction that it takes to get to the data. So with that, I'm gonna give you a chance to wire some of this up. Go ahead and add that tools array to your UI chat resource and create a get lights tool. You can add a asynchronous handler function that calls the fetch lights method on the smart home service, and then expose the light card component. That way it knows how to show light cards to the LLM. And please tell me if I'm going too terribly over time, and I'll wrap this up quickly. Otherwise, I'll probably do at least one more challenge, and then I can wrap it up.
Yeah, I think we can do one more challenge.
Cool. So yeah, we'll spend just a minute or two on this one, and then I'll move on to the next part of this. I really appreciate it, Marcus. Yeah, we've worked hard on the end-to-end experience of Hashbrown, though I would love all of y'all's feedback on it. It's a very new library. We're just at version 0.1. We've got a lot of maturing to do for this library. And so, yeah, if you use it and play with it and have some feedback, boy, we would love to hear it.
Yeah, totally. I think that Gen AI, sometimes it feels yeah, like a little bit of janky experience. Like the power has always been there, right? Like you know that it's so great, but the developer experience has been a little bit janky. So it's insane that you kind of get, the powers of Gen AI by having like a really clean developer experience. Like developers are familiar with SOD, you're familiar with like these structures that you kind of set up, and the Angular developers, being able to just open Redux dev tools and stuff like that. Really, really great stuff. Yeah, really, really amazing job.
Thank you. Really appreciate that. Yeah, it definitely has been, like I said, when we were asked where did Hashbrown come from, it was born out of those same sets of frustrations. Brian and I had been building with AI for the past couple of years and exploring this concept. And yeah, Hashbrown's that tool we wish we had, We wish we had Hashbrown, so we went and made it.
Mm-hmm. You end up doing a lot of like wiring up, and like you can use the OpenAI SDKs directly, and they're good, but they obviously serve a very broad use case. And so we've really done, I think, a good job of kind of narrowing that down to kind of what the front end developer experience should look like, at least in our initial attempt at striking something like that. And we'd love to hear how close we got to that, where those frustrations might lie, or kind of where those really easy wins are. So yeah. We got a question from Matt. How complex can the components you feed the LLM be? Can the component call a service of its own with API calls? So I think he's talking about like a smart component, or maybe like a stateful versus a stateless component.
It's just a straight up Angular component. There's no limitation on it. It can be as complex as you'd like, and you don't have to render this as a chat experience like that chart example we showed earlier.
Mm-hmm.
Kind of the way that was working is it was chat, but didn't look like chat. And like the schema for that was the entire schema for chart.js. Like it was really able to handle a very complex, large and nested schema without any problem. So yeah, I would say that right now I've not hit those kinds of limitations, but together as a community, let's go find out. Let's go push this as hard as possible and see what actually works and what doesn't work. And I'm sure as these models keep getting more and more capable, I think the horizon will be pushed out. Yeah, one of the things I'll say about that, Matt, is not only can it do its own API calls, but I think it's one of the really cool benefits of Hashbrown. There's a lot of companies that are building chatbots with this idea called RAG. It's basically a retrieval of knowledge. And the way that those typically work is it goes and retrieves knowledge, and then it generates a bunch of text back out. And that can still have some hallucinations in it. And with Hashbrown, instead of using RAG to generate a bunch of text, you can have RAG generate components with UUIDs. Like if it messes up a UUID or hallucinates a bad UUID, that's so much easier as a developer to deal with. Like I can, take that UID, make a network request. If I get a 404, I can like really handle that in a nice way. Not only can the components be really complex, but moving complexity out of what you're asking the LLM to do and into your Angular components saves on tokens and improves the quality of the chat experience.
Yeah, I think there's something to using integrating your existing components into generative UI. So those components are trusted, you can test them. Perhaps there's compliancy or regulation around them. And so that's something that you own as the team or the developer. And so we're just exposing those components out to the LLM, and then generating that in the UI. So I think it gives you a lot of power, but also a lot of like safety and security around things, where, like Mike said, with hallucinating and things that might be really important when it comes to like maybe a stock application or a financial application, where that can be detrimental to your organization. Using trusted, authoritative components that are tested and compliant, I think, provides a lot of capabilities and a lot of security around this, because I think that's a question that a lot of, I think, businesses and organizations are like, well, wait, what about, what's the risk here? And so I think that minimizes a lot of the risk.
Yeah, for sure. Okay, so we've shown it getting the lights, but what about control? And, we showed earlier that LLMs can bind data, or we can use the AI to bind data to inputs. And in the same way, we can also create tools that accept data as arguments to them. So if I wanted to give it the ability to control lights, for example, I could create a tool with arguments. And here it's mostly the same. I'll call this control light, and I'll give it a description, control light in the smart home. But what's different is now I'm going to provide it the schema for the arguments that I want. So here I'm going to drop a little bit of skillet schema and tell it what I want it to generate as the arguments for this tool. So I'm going to ask it to generate an object for the control light input. And I need 2 bits of information. I need the light ID to control, and I also need the brightness as a number. So now that I've done that, I'm going to create a handler function here. And if I hover over args, we can see that it's all nicely typed. We can see that I'm going to get inside of this an object with a light ID and a brightness on it. And so again, I'm going to inject that smart home service. And then I'm just going to call control light with the ID of the light and the brightness that I want it to control. And I'm also gonna, yeah, I'm glad that Cursor got that. I also want to go ahead and specify sort of the range of these numbers. One of the things that might be surprising is that the schema that LLMs support today when generating structured data is very, very limited. And I think OpenAI is the only model of families that actually would support a more structured min and max values. And that's new as of like a week ago. Model families like Gemini don't really actually support min and max on these. And so we often have to tell it the constraints in natural language
The
as part of
description. Mike, is there a limitation to the length of the description?
No, I mean, it's basically going to
It's
count
like
against
it's
the
another
token.
prompt, right? It's basically another prompt here, right? I can kind of describe it and really contain it and give it the limitations and all that kind of stuff.
Yep. So a lot of these models have what's called like a context window, and there'll be some kind of maximum. And so you might go read like the OpenAI documentation, and it'll say that a model has a million token context window. And I'm not going to get too deep into what a token is, but assume that a token is about 4 characters of text. And so your total prompt could have about 4 million characters in it. So feel free to be quite descriptive and verbose. I think 4 million characters can be is quite a healthy limit. There's a lot you could describe with 4 million characters. So now that I've done that, I'm going to go back to my application, and now I can say something like turn off the bedroom lights. And so now it's going to get the lights, and then it called control light 3 times to turn off those bedroom lights, and we saw our application update in response to that, and it was kind of able to string all of that together. So in the interest of time, there was a challenge part 2. I'll just pause here for a second so you can read it, maybe take a screenshot of it, and it'll be there for the recording for anyone who wants to follow along later on. But yeah, using create tool with args allows you to not just let the LM call your services, but call your services with generated arguments that it has discovered as part of its flow. And that's what we wanted to show you with Hashbrown. There's so much more to it than we were able to cover in an hour. So if you want to learn more about Hashbrown, you can check us out at hashbrown.dev. The really cool part about Hashbrown, in my opinion, is that it is 100% free and open source. It will always be free and open source. I have such a deep love for open source in my heart. As y'all know, I worked on NGRX previously. And so I'm just excited to give this to everyone and hopefully really build a community around it. In fact, we've already got a number of contributors. There's probably lots of faces here. That's where the sneaky Brandon, why he appeared there. He actually made a pull request like an hour and a half ago. I'm like, I'm adding you to my Slack before the meetup starts.
I love it. Yeah,
Uh,
that's great, man.
If you want to contribute to Hashbrown, we would really love to have your participation in it. We want to grow a community around this. We think that there's a lot of really cool ideas. And if you want to support the project, like I said, it's free and open source. You can just use it. But if you want to support it, the best way to do that is to work with Brian and I. We are the founders of a consultancy called Live Love App. We are super excited about generative user interfaces. And so if you want some help, some training, or some partners to help build alongside you, we would love to do that via Live Love App. And so with that, I'm curious to hear, what is it that you're going to fry up with Hashbrown? Thanks for having us. We really appreciate it.